Okay, so we've done finding greatest common factor of integers, of terms that have variables in them, and now I want us to look at factoring the greatest common factor out of a polynomial. So remember, a polynomial, you might not remember, has more than one term, right? So just as a reminder, right, we might have ax plus bx, okay? This is a polynomial, and each of these is a term, okay? And that's because terms are separated by addition and subtraction. All right, so that's an important distinction to keep in mind. So let's just think about, let's say, as a basic thing, we had 5a plus 15, and I said find the GCF or factor. We're not finding the GCF, but we're factoring the greatest common factor out of this by looking at each term and seeing what they have in common, right, as a greatest common factor. Now, looking at this one, it's pretty easy, I think, because 5 is a prime number and it goes into 15, okay? So I'm going to factor that out. 5 factors out. And what do I get here when I divide 5a by 5? I get a, right? It's 1a. We don't write the 1. And when I divide 15 by 5, so remember, this is what I'm doing actually. I'm dividing by 5. When I divide 15 by 5, I get 3. And now I've factored that polynomial. Okay? Now, we would do, right, these all very similarly. So if I said 56x plus 8, okay, well, looking at this, just on the face of it, I know 8 goes into 56. So I don't have to necessarily go looking to see what the factors are. But if you do, then do so, right? What do I know about 8? I know that it's 2 times 2 times 2. What do I know about 56? I know it's 7 times 2 times 2 times 2, right? It's 7 times 8. So what do they have in common? And then times x. They have in common is 2 times 2 times 2, right? So the greatest common factor of those terms is 8. And when I take that out, I'm actually dividing 56 by 8, so I'll get 7x here. And 8 divided by 8 is 1, which I must write because it's the only thing in that term. Okay? If there was a variable with it, I wouldn't write the 1, just like I didn't write it up here. So finding greatest common factor, or factoring out of polynomials. So let's look at another one. This one's going to probably not be too challenging, I hope. So y cubed plus 2y. So this is a polynomial, even though, and it's got 2 terms. Even though the terms don't, this one technically does have a 1 in front of it, right? They don't have to be that way. It could, you could have just 1 plus 2y be the same. So factor things out. Now here the factors of this are y times y times y, right? And the factors of this are 2 times y. So what do they have in common? They have a y, right? So I factor out y, and then I just say y cubed divided by y, right? Well, that's y squared if you follow the rules of exponents. And then plus 2, right? Because y divided by y is 1. So it's just plus 2. So this is factored form of y cubed plus 2y. And I want to do maybe a couple more, and we'll just see. I like to keep these videos as short as possible, but you know, these get kind of complicated sometimes. So let's look at this one. 16x to the 5th plus 8x to the 3rd minus 12x. Okay, now there's 3 terms here, right? So I need to treat each of these. So 16x to the 5th, that's 2 times 8. 8 factored is 2 times 2 times 2. So 2 times 2 times 2 times 2, right, is 16. Times x times x times x times x times x. There has to be a shorter way, and as a matter of fact, there is. We wouldn't have to write all those x's out, and I'll show it to you in a bit. And then 8 is 2 times 2 times 2, and then I have times x times x times x, right? And then 12 is 2 times 6, which is 2 times 2 times 3, and then times x. And then I just look for, right, the common, right, the common factor in each term that I'm going to factor. I'm going to factor that out. And so you have a 2 in common. You have another 2. No more 2's in all 3 of them, right? They each have an x in common. They don't each have a 3, and that's it, right? So 2 times 2 times x. So we're going to factor 4x out of this, okay? And so 16 divided by 4 is 4. X to the 5th divided by x is x to the 4th. Plus 8 divided by 4 is 2. And x cubed divided by x is x squared. And then 12 divided by 4 is 3. And x divided by x is 1. So here's what we get, right? We get 4x times 4x to the 4th plus 2x squared minus 3. Now you might also, when we're doing this, I hope that you're starting to notice that we're really kind of doing the opposite. As a matter of fact, we are doing the opposite of distribution, right? Because if I distributed this y in here, I would get y cubed plus 2y, right? If I distributed this 4x, that's what I would get up here. So I'm undoing distribution by doing this. And you know, they get a lot more complicated, but I'm not going to do another more complicated one right now. I'll get to it in the next video.